everyone, welcome to Mrs. Shin's class. Today, let's have a go at differentiating the parametric equations. So, what is parametric equations? That occurs when the variable, for example x and y, are both defined in the terms of another single parameter. Majority of the times it's t. Okay, so what I mean by that, there you go, I have both equation and x and y, and both equations are in terms of t. Okay, so our main goal here is to find dy over dx. Okay, but in order to do so, what we need to do is we need to differentiate x and y functions separately. Like this for x, I'm differentiating x in terms of t, and differentiating the y function, I'm differentiating y in terms of t. Okay, so using the chain rule, the differentials, okay, using the chain rule we can make up dy over dx just like this. Okay, dy over dt, because y is at the top, I put it on here, or vice versa, it doesn't matter. And we want dt to be at the bottom, so I flipped it and multiply it like that, so I can cancel out dt and dt, so dy over dx remains. Okay, so this is about parametric equation, so let's have a look at the questions. There you go, this is what the question looked like. It says differentiate the pair of parametric equations. X function is equal to t squared, whereas y function is equal to 4t. Right? Our main goal is to find dy over dt, right? So we have to differentiate each function in terms of t. So if we differentiate the first one, the function x, 2 comes down, so 2t, whereas y, it's going to be 4, right? Okay, let's find out dy over dx. Okay, in order to make dy over dx, what do we need to do? Right, y, dy at the top, so I'm going to use this one, times, okay. Alright, so I want x to be at the bottom, so I'm going to flip it and make it dt over dx. So what I mean by flipping it is dx over dx is 2t over 1. Okay, and I'm going to flip this, and dt over dx, it's going to be 1 over 2t. Okay, so I just flipped it and then rewrote it on there. Okay, so like this, dt will cancel out, and all I remain will be dy over dx, as if on the left hand side. Okay, so let's substitute the values in. Remember the dy of dt is 4. dt over dx is not this one, but this one, right? So it's 1 over 2t. Okay, so let's simplify. There you go. This will be your final answer. Okay, it's not too difficult, is it? Okay, before we move on to the next question, let's have a look at this one. Right, y function is in terms of x. So if I differentiate it, we go dy over dx, because we're differentiating in terms of x, like this. And second derivative, if I do it again, okay, I differentiated y twice and dx twice, right? So d2y over dx2. This is a normal differentiation that we covered so far. However, today, for parametric equations, okay, you have something like this. You have two different functions, both x and y, in terms of t. Okay, in this case, you're going to differentiate it, each one, by t, so dx over dt, dy over dt. And remember, in order to find dy over dx, we use chain rule to calculate it. Remember, since both of them will be in terms of t, even though you multiply it, it will be in terms of t. Remember our previous question, right? Dx over dt dy over dt, it's all in terms of t, so dy over dx, okay, our answer was in terms of t. So if we were to find second derivative, okay, of the function, what do we have to do to this one? We have to differentiate again, right? But this was in terms of t, so what this means is I'm differentiating dy over dx function in terms of t, okay? But, okay, you see I have two d's, one y, yeah, that makes sense. However, at the bottom it's dt over dx, whereas I have dx twice, right? So therefore, dt should be eliminated. That means I need to multiply dt in order to make it disappear. Over, I need extra dx, right? So I'm going to add dx like that. Okay, so if we redo it, I have two d's, d to the power of 2, y, dx, I've got dx twice. Okay, this will be the formula for second derivative of the parametric equations. Okay, this is a question. It says find the second derivative of the pair of the parametric equations, x function and followed by the y function. Okay, so remember the formula for the second derivative is this one, right? So what do I need to find out in order to do that? I need to find out dy over dx, okay, the first differential equation. I need to find out dt over dx, okay. Let's have a go. There you go, step number 1, I differentiated each function, and then I'm going to use chain rule to find dy over dx. Okay, my chain rule will be dy over dt times dt over dx, so I can cancel out dt, and all I left is dy over dx, like left hand side. So dy over dt I already calculated, which is 3. Okay, whereas this is dt over dx, and I have dx over dt. What is it? I need to flip it. Yeah, so this is 8t over 1, so if I flip it, it's going to be 1 over 8t. You see that? So there you go, my dy over dx will be 3 over 8t. Okay, so if we come back to this equation, right, we found out dy over dx, and we know dt over dx, okay, dt over dx was 1 over 8t, right, so we can calculate the rest. Remember this one, that means I'm differentiating dy over dx once again in terms of dt. Okay, so this here means I'm going to differentiate this dy over dx once again. So here I let dy over dx in negative power. I'm going to differentiate this in terms of what? In terms of t, like this. You get it? Okay, so negative power comes down, okay, and in the power I'm gonna minus 1, okay, and according to the chain rule I need to differentiate what's inside, right? So I need to multiply by differential of this, which will be 8. Okay, so if I simplify this, okay, it'll be something like that, right? And then, okay, there you go. If I simplify, it's going to be negative 3 over 8t squared. Okay, so let's bring this paper again. So d2 dy, I know what this is, which is this value, okay, like this, and dt over dx would be this value, dt over dx 1 over 8t, just like this, right? And let's have a go at simplifying it. There you go. This will be your final answer, okay, because it's a second derivative of the parametric equation. Okay, let's have a look at this example. This is one of the excellence question. Okay, Right, what do you need to do? This is a parametric equation. So I need to differentiate the x in terms of t. I need to differentiate y in terms of t, right? Okay, but this is trig functions. So remember this chart? Yeah? So you need to look at this one and see how you can differentiate the trig function. So let's have a look at the first one. Okay, so I have sine. When you're differentiating the sine, okay, it will be cosine, right? So therefore, I just change sine into cosine, and there you go. I differentiated x function in terms of t. Okay, whereas this one, how can I differentiate the cosine? So if I differentiate the cosine, it's going to be negative sine. There you go. I differentiate it to negative sine. Okay, and here I simplify the equation. What do I need to do next? I need to find dy over dx using the chain rule. Okay, like this. Again, this is dy over dt over here, and dt over dx. Okay, over from there. But remember, I need to flip this one because this is the x over dt, but what we want is dt over dx, so flip. Okay, there you go. This is the first differential equation, and if I simplify this, it will be something like this. Okay? Now, what we want is not the first differential, but the second derivative. Okay, let's bring this paper again. So second derivative, remember, I have to differentiate dy over dx once again, and times it by dt over dx. So I have dy over dx here in terms of t. This part, okay, that means I'm going to differentiate this once again, times dt over dx. Where do you find it? dt over dx that you flipped from dx over dt. There you go. You're just going to multiply this value. Right, so have a look at this one. I want to differentiate this one. However, this is a function over function. How would you differentiate this? Yeah, there was a hint over here, right? The quotient rule. We have to use a quotient rule in order to differentiate a function over function. Okay, so you differentiate each term one by one, and f dash x times gx minus the normal fx times g dash and the normal gx and square it at the bottom. So shall we have a go? Okay, here you go. I let the top one fx, the bottom one gx. Now we're gonna differentiate this. Remember sine, it's gonna change it into cosine, so it's gonna be like this. Whereas gx, it's cosine, differentiating into negative sine. So there you go. I differentiated each term. Now let's apply the formula. Okay, I'm differentiating the first differential equation. The first one is f dash times gx, like that. Okay, this time it's followed by minus the normal fx and times it by g dash. This function will be divided by the normal gx squared. So the normal gx is this one, so therefore it's going to look like this, right? Let's simplify. The first section, negative 5 times 4 cos will be negative 20 cos squared t. Okay, it's followed by negative 5 times negative 4 is positive 20, sine will be sine squared, and minus in front, so therefore minus 20 sine squared t. And I just let the bottom one as it is. Okay, here I'm just following the formula again. So now we found the first part, which is this one. Okay, like this. And dt over dx, remember, it was 1 over 4 cos t. Okay, if I multiply the top, it's as it is, and calculating the bottom, simplifying the bottom, 4 squared will be 16 times 4 would be 64, and cosine squared times cos will be cos to the power of 3t, right? I think I can simplify further, right, by taking out negative 20 from both sides, like this, and top and the bottom, 20 and 64, I can cancel out to negative 5 and 16. And remember this one, cos squared plus sine squared, this will be equivalent to 1, right? So therefore your final answer will be this one, okay? Okay, so in this excellence question, it was asking you to remember how to differentiate the trig function. Also use the quotient rule, and you had to remember that this one is equivalent to 1. Okay? This is what we did in term 1 this year. So there you go. This was all about the parametric equation. I hope this video helped. Okay, now it's your turn to have a go at doing some more questions. Okay? I'll see you in the next lesson. Bye-bye.